Hi and welcome back. So as we saw, when we define a function inside a class, how it behaves as a function or a method depends on how the function is accessed, from the class or from the instance. And we've seen that by default, when we define a function inside a class and we call it from the instance, it will be bound to the instance. It will become a method bound to the instance. So just to review that, we create this class person. We can create this function in the class, and let's say arg equals default. So we'll specify a default value for that. And then we can say printf hello with arg equal to arg. Okay, so this is our function that we've defined in the class. Now, if we call hello from the class, let's see what happens. Well, if we spell this correctly, you can see that the argument value was default. That means nothing was actually passed. When we called hello from the person class, it was called as a regular function. Since we didn't specify a value here, nothing was called. If we called it with a value, we would get that. So calling the function from the class was called as just a function. Now, if we create an instance of person and then we call the hello function from the instance, you'll see that the argument that was passed to hello was the person object. It was this object P, and that's because it's behaving as a bound method and it's bound to the instance. Now, sometimes we want to define functions in our class that don't really interact with the instance itself, but maybe it needs to interact with the class. In that case, what we want to do is we don't want the instance to be passed to the function no matter how it's called. Whether it's called from the class or called from the instance, we want the class to be passed as the first argument of that function, of that method. So these are called class methods. In Java, if you're familiar with Java, those are very often referred to as static methods. So they're basically global to the class, but not to the specific instance. So they don't get bound to the instance, they're bound to the class. Let's go ahead and define that. So let's say class, my class, and let's define the hello function. Okay, so at this point, this is really going to be, if it's called from the instance, it's going to be an instance method, right? That's the default. So let's create this function. Then let's go ahead and create this other function here called instance hello, and this will also be called from the instance as a bound method to the instance. And in this case, though, I am going to allow passing in the argument because that's going to be the self, essentially. Okay, so some of these things will work, some of these things won't work. We'll take a look at that in a second. So here, I'm just going to return this f string. I'm going to print this f string, I should say. Then I'm going to define something else. I'm going to call this the class method. So the class hello, and that's also going to receive an argument. And I'm going to say the same thing, print hello from whatever the argument was that was passed in. The difference here is I'm going to use this class method decorator. And as I explained in the lecture, this now means that whenever I call class hello, either from the class or from the instance, it will be a method, but it will become bound to the class and always to the class. So let's take a look. I'm going to create this instance of my class. Now, if I say my class.hello, that will work just fine because basically hello is a function and it's calling this one. But of course, if I say m.hello, that is not going to work because we're missing that first positional argument that Python injects because it thinks that we want hello to be an instance method. That's the default behavior for functions that are defined inside a class. So if we do m.instance hello, that will work now just fine, and it will say hello from this my class object, which is basically an instance of my class. Now what happens if we call the class hello? If we call class hello from the instance, what happens? Well, you'll see that it works correctly, but look at what the argument was. It was my class. It was the class my class. So the class was received here as the first argument. Now, if I call class hello from the class itself, so the class is my class, so I can say my class dot class hello, then you'll see that it also receives my class. So class hello, from this perspective, from the perspective of the class, let's see what the type is. It is a bound method, and that's because we used this class method decorator over here. The instance hello, from my class's perspective, is just a regular function. The same thing with my class dot hello. That's also just a regular function. But from the perspective of the instance, then m.class hello is also a method, but it's bound to the class. And on the other hand, hello is an instance method. So it's a method that's bound to the instance of my class. And then the same thing with the instance hello, it works the same way. Okay? If I can type it right. So we get a bound method that's bound to the instance. So far now we've seen functions that we can define in classes that are either going to be bound to the instance, such as these two over here. So this will never work from the instance because it needs this argument in order to work. We also now have methods that are always bound to the class, no matter what, no matter how they're called, because of this class method decorator. Now sometimes we want functions in our class to never be bound. We don't want them to become methods no matter how we call them. Whether we call them from the class, like hello, right? It was actually a function when we called it from the class, but if we called it from the instance, it became a bound method. And we want sometimes to be able to define functions that are never bound, that never become methods. So in order to do that, we have another decorator that I talked about in the last video, which is the static method decorator. So we can use it at static method, and now I'm going to call it static hello. Now, because it's a static method, it doesn't actually get anything injected. So we can write a function that doesn't have any arguments, and it will work just fine. And say, here, we're just going to say static method called, like so. Now, of course, if we have arguments, then we'll need to provide arguments when we call static hello. But once we have that, we can now create the instance of my class, and now we can call my class dot static hello. And as you can see, it works just fine because in fact, my class dot static hello is not a method. It's not bound to anything. It's just a function. And if we do it from m, so if we do m is an instance of my class, and I call m dot static hello, it also works just fine. And that's again because the static hello is now a function. It remained a function. Python did not turn it into a bound method. So let's take a look at a more concrete example that uses these different method types and mixes it in. As I mentioned in the lecture, the static methods are sometimes discouraged by certain developers. And if you look, for example, at the Google guidelines for Python programming, they actually discourage using static methods. And that's because there's really no need for a static method. You can define your functions at the module level, and they'll be available inside the class, and they'll behave like static methods, but they won't be inside your class. So they're a little easier to call because you don't have to prefix them with either the object, instance or the class, and say class dot static hello, for example. So you don't really need static methods, but some developers like putting their utility functions that are related to a specific class inside the class. And maybe it makes sense to do that. So that I'm going to leave up to you as to whether you want static methods or not. But let's see how you would use all of these together at the same time. And certainly the class methods make sense. So I'm going to do that timer. So let's go ahead and say from datetime, I'm going to import the datetime class. I'm going to import the time zone class and the time delta class. Now again, when you work with time zones, I would recommend using third-party libraries. The built-in or standard library time zone handling in Python isn't great. It works, but you have to be careful with a lot of stuff. So some of these third-party libraries like PyTZ, for example, will help you deal with time zones in a much easier way. Here, I just want to stick to the standard library. So let's go ahead and create our timer class. So for that, I'm going to have a class property called tz, which I'm going to set to timezone.utc. So this is a class variable that's set to the UTC time zone. Next, I'm going to define a class method because I want my time zone to be the same for all instances of timer. My program is running in my time zone. I want all my timers to be in the same time zone, and I don't want to have to go to each one separately, each instance of timer, and set the time zone maybe to Mountain Standard Time, which is my time zone. I don't want to do that. I want to set it once and have it apply to all the instances of timer. So that's a class level variable. And in order to set it, instead of doing just the bare attribute, I'm going to use a class method. So I could probably do, an underscore tz to indicate that this is a private attribute. But for now, I'm just going to set it this way. And I'm going to create this function called setTz. And I'm going to decorate it with the class method, which means the first argument of that function, when it gets called as a bound method, will be the class, will be the timer class. And I'm going to want additional information when I set the time zone. I want the offset from UTC, plus or minus a certain value, and also pass in the name that you want to assign to that particular time zone. So here now, I'm going to modify the class time zone, and I'm going to create a time zone object out of it. And so I'm going to use a time delta, and I'm going to set hours equals offset. So here I'm really only using hours for the offset. Again, time zones is more complicated than that. You have time zone offsets that are hours and minutes. Here I'm just saying, okay, just pass me an integer offset and I'll use that for the offset. So we'll do that. We'll create this time delta as the offset from UTC and then whatever the name was. So I'm going to create this time zone object and set that at the class level. Okay, so now we have this. Let's try it out. So we can say timer.setTz, and I'll set it to -7 and call it Mountain Standard Time. So now if I look at timer.tz, I have that as a datetime time zone. Now if I have multiple instances of timer, T1 and T2 equal to timer, then you'll see that I have the same time zone for both. So now I can actually look at the time zone from the T1 perspective and from the T2 perspective, and they'll both be using the one that's defined at the class level. So now, for example, I could reset my time zone at the class level. So I'd call the setTz, set it to -8, and then specify, let's say, PST. So now if I've done that and I look at the time zone 1 time zone or the timer 1 time zone and the timer 2 time zone, you'll see that both of them now reflect PST, or this -8 offset. So next, I want to implement a function in my timer class that's going to return the current UTC time. So let's go ahead and copy this class and put it down here. Well, if I think of my current UTC time, so I can create this function called def current UTC, current date time UTC. Let's call it that. And it's going to return what? Well, it just needs to return the current date time, so now, and I want to specify my time zone to be in UTC. If I just leave the function like this, it's going to be bound to the instance when I call current DTUTC from the instance. I don't really need information from the instance. There's no information in here that relates to the instance. So maybe I should make it a class method. But if you look at this one, there's nothing in the class that I need either. So technically, this is a function that could even exist outside of the timer class, but at the very least, I can make it a static method. I can decorate it with a static method decorator, which means it's always going to come back as a function that's not bound. It will never become a bound method. So we could do it that way. So now we can use our timer class. So I can create the timer object, and now I can go ahead and call t.current DTUTC. That will work just fine because it's a function that's not bound to the instance. And I could also call it from the timer class directly as DTUTC. Okay. But what I cannot do is call it directly this way, current dt UTC, because that's not defined in my module, that's defined in the class. So if I wanted to be able to do that, then I should just take this function out of the class and put it in the module and use it that way. And then in this, if I ever need current dt UTC in my class, I can just call it directly. I don't have to reference it as being inside the class because it's loaded in the module. So this is why the static method is really not necessary. The next thing I want to do is to return the current time, but adjusted based on the time zone of the timer. Now my timer uses a time zone that's at the class level. So let's go ahead and write this method. So now I'm going to want to write and just say current dt. But notice I don't have UTC on it. So what do I want to do there? Well, I want to return the datetime .now, okay? But I want to specify it in the TZ time zone. But what's the TZ time zone? It's defined in the class. So really here what I want to be able to get a handle on is the class. Well, that's easy. I can make this a class method. Now you'll notice I don't need anything from the instance. I can just get the current date time and then convert it to that particular time zone. So now I have this class method. Let's go ahead and try this out. So if we do current dt UTC, okay, I can do that. I'm doing this from the class. Now, what's the default on my class right now? What's the time zone default? It's UTC. So if I do timer.current dt, okay, again, I don't need an instance to call either of those two methods because one is a class method, the other one's a static method. And as you can see, I get my results over here. Now, of course, if I create my timer, so I can say timer, and T2 is also equal to a timer, then I can look at current at T1.current dt UTC, or I could look at T1.current dt, right? That will work just fine in both cases. Now, if we change the time zone, and we can do that either via the class or the instance. Now, if you change the time zone directly using TZ, using the .tz, then you got to be careful because if you change it on the instance, it's going to become an instance property. It's going to go into the dictionary, right, of T1 or T2. But if we call the class method, then it's actually going to change the class TZ. So let's see how that works. Let's say that I say now T2.set TZ -7 and then MST. So now I'm calling that on the T2 instance. So yes, I'm calling it from the instance, but setTZ is what? It's a class method. It's bound to the class. So if I look at T1.tz and T2.tz, you'll see that both of them are Mountain Standard Time. Neither T1 nor T2 have that TZ in their dictionary. That's at the class level, and that's because I called a method that was bound to the class that modified the value on the class. So now if I call T1.current dt, and if I call T2.current dt, and if I also call T1.current dt UTC, just so we can see that there's a difference now, you'll notice that this is our UTC timestamp, and these now are our MST timestamps. So the first thing I want to do is I'm going to have exceptions sometimes when I do things on the timer. So I will cover exceptions in a lot more detail, and I will talk about those after we've done inheritance. For now, let me just show you how I define custom exceptions. I define a class that's timer error, and I inherit from the exception class in Python. We'll talk about all that in a lot of detail later. For now, that's all I'm doing, and I'm going to put it, give it a doc string. So custom exception used for the timer class, okay? And I'm going to do that. Now, you do not need a pass over here, even though this is an empty class, and a class has to have some code in it. So very often we'll use pass. You've seen me use that before. It's a no-op. But in this case, we have a statement in the class. What is the statement? It's this, okay? the doc string is not a comment, right? Some people sometimes say, well, this is a comment. No, this is a multi-line string that I've created inside my class. I haven't assigned it to a particular value. I haven't said a equals that, but I still have created it in the class. It's a piece of code. It gets compiled. That means that timer error has code in the body of that class. So I don't need the pass, okay? So now the next thing that I want to do is to go back to my timer class. So let's go ahead and copy paste this code down here. So I've got my class methods, my static methods. Now what I want to do is I want my start and stop. So the first thing I'm going to do is basically create a method called start, and it's going to be an instance method because I want it to be tied to the instance of the timer that I'm starting and stopping. Now internally, I want to do everything in UTC, and only at the very end when I display results to the user am I going to convert it to whatever the time zone is on the timer. So I'm going to go ahead and say time start equals self dot current dt UTC. So I'm going to call the static method current date time in UTC, and I'm going to set my end time equal to none. If I'm starting the timer, I'm going to clear out the end time because it may have been started and stopped and then restarted later, in which case I need to clear out the end time. So I'm going to do that, and I'm going to do the same thing with stop. Again, it's going to be an instance method, and here I'm going to do the same thing. I'm going to say, well, first of all, I am going to check that if you try and stop the timer and you haven't started it, that should raise an exception. You shouldn't be able to stop a timer that hasn't been started. Well, it hasn't been started if time start is none. So if self dot underscore time start, and there's different ways we can do this. I'm just trying to show you some of the things that we probably want to be careful with. So if self dot time start is none, then I'm going to raise a timer error, and I'm going to set timer must be started before it can be stopped, like so, okay? Now, if I don't have an exception, that means the timer was started, and so now I can set the time end private attribute on the instance to the current date time, again in UTC. So that's my start and stop methods. Now, let's go ahead and create some properties so that the user can query some of these values. Well, one of them is the start time. So let's go ahead and create this property and call it def start time. And so what I'm going to do here, I'm going to say if self dot underscore time start is none. So if there was no starting time, then I need to raise a timer error. And so I can make a custom message here. Timer has not been started. Okay. If we don't have an exception, then I'm going to return the start time, but I'm not going to return self dot underscore time start, because now I'm reporting something back to the user. The user told me what time zone they want to use, so I'm going to convert that to the appropriate time zone based on that offset that I have. So I'm going to return the time start, but in this new time zone. Next, I'm going to do the same thing for the end time. So at property def end time, and again, this is going to be an instance property, so self, and I'm going to do the same thing here. If self dot underscore time end is none, that means that I haven't stopped the timer. And so I'm going to raise a timer error exception again and say timer has not been stopped, like so. And there's lots of other checks we can do. I'm trying to keep it simple, but still show you that we should do some minimal checking. So if we don't have an exception, then we can say self.time underscore end as time zone. So again, I want to go ahead and get the time zone. Now you'll notice in both these cases, I'm using self because the time zone is defined where? In the class, right? At the class level, it's a class attribute. Even though I'm saying self.tz, Python doesn't find it in the instance, it's going to go back to the class and find it over there. Okay, so now we have these two properties. Let's do another property. That's going to be our elapsed property. At property, and we're going to define the elapsed property, which is again an instance property. And the thing is, if my timer hasn't been both started and stopped, so if either time start or time end is none, then I want to raise an exception. So I could do that. So definitely I'm going to do that for the time start. So I'm going to say if time start is none, well, there's no way that I can give you the elapsed time because you didn't start the timer. So let's go ahead and raise a timer error. So raise timer error, and we'll say timer must be started before an elapsed time can be calculated. Something like that. I could do the same thing with time end, but I'm going to do something a little bit different. I'm going to say if self.timeEnd is none. So if the timer hasn't been stopped when you call the elapsed time, I'm going to just return it. I'm going to look at the current date time and return that elapsed time from that. So I'm going to say elapsed time is equal to self.current_DT_UTC. So I'm calling the static method minus self._time start. So what's happening is that I don't have to stop the timer in order to calculate the elapsed time. So I'm not going to stop the timer. I'm just going to look at the current date time in UTC, calculate the elapsed time based off of that. If the time end has been set, then I am going to use that for the elapsed time because that means the time has been stopped. So that's what I should be using. So I'm going to say self.time_end minus self._time start. Okay, that's my elapsed time depending on what was set up. So now I can go ahead and calculate the elapsed time, and I'm going to get the total seconds that were elapsed. Okay, so there's probably other things that we could do in terms of the start and the end, starting and ending and clearing out the values. There's probably a lot of refinements that can be done on this class. I just wanted to do something to show you how we can mix, static methods, class methods, instant methods, properties, and so on. All right, so now that we have this timer class defined, let's go ahead and just use it. So from time, I'm going to import the sleep function. And that's because I want to be able to start the timer, pause execution for a little while, stop the timer, look at the elapsed time, look at the end time, and just basically run a few steps through this timer class and make sure everything looks okay. So not exhaustive testing by any means. So I'm going to create a new instance of that timer. I'm going to start the timer. I'm going to sleep for about 2 seconds, and then I'm going to stop the timer, and then I'm going to print. I'm going to print, let's say, this interpolated string start time. So that should work just fine because I did start the timer. Let's say t1.start_time. I'm using the property start time. So that's going to return to me the start time in my time zone. Now I haven't set the time zone yet, but we'll see that. So I'm going to do that. And which means, by the way, the default is, of course, UTC. So I'm going to do the end time. And here I'm just going to do t1.end time. I'm going to interpolate that in. And then we're also going to look at the elapsed time. So elapsed. And then here we're going to say t1.elapsed. And then we'll say here seconds. Okay, so let's see if all this works. And it worked. So as you can see, we get our start time. Now you'll notice the offset is 0 hours. So these are UTC timestamps. So we have our start time. And about 2 seconds later, we have our stopped that happened. That's when we ended. And so our elapsed time is 2 seconds. Now I can do the same thing with the second timer. T2 equals timer. So now this is a second timer. I can start the timer. I can sleep for 3 seconds, let's say, and I can stop the timer. And then I'm just going to repeat the same thing here. So my timer 1 exists, but now T2 is a separate instance. I run that, and of course it's going to have its own internal data for the instance, for the start time and the end time and the elapsed. Okay, so we get these various results. And of course, I'm getting 2 seconds here because I actually am calling it on T1. I just need to fix this and call it T2. Okay, so we should get about 3 seconds of elapsed time. And there we go, 3 seconds. So our timer works. Now, furthermore, let's say I want to use Mountain Standard Time, MST, throughout my application. Well, then all I need to do is to go to the timer, and I can use the setTZ function, which is basically a class method, right? When I call it that way, and I can call it from T1 or T2, it doesn't matter. It will have the same effect as calling it from timer, because I'm going to be calling the class method, because it's bound to the class, no matter how I call it. So here I'm going to call it directly from the class. So that's going to set now my time zone. So if I again print out the start time and end time and elapsed of T1, you'll notice that what I get now is with the offset. So it ran this at 7:30 p.m., right, on this day, and it finished then. And if I do the same thing with T2, so I can take what I had for T2, then again, it's going to be now based on the MST time zone. All right, so thanks for watching, and I'll see you in the next video.